Hey, welcome back, Math Gurus. In this video, we're going to talk about similar figures, and we're actually going to do problems that involve like shadow and height. Okay, so let's get started. A building that has a 24 feet tall, a building that's 24 feet tall cast a 96-foot shadow. At the same time, the telephone pole cast a shadow that's 144 feet. How tall is the telephone pole? All right, so I usually kind of categorize this into the proportion, the similarity unit, and similar triangles. And I really say triangles because I'm about to show you what I mean. So the building is 24 feet tall, and its shadow is 96 feet. So now let's look at the telephone pole. We don't know how tall the telephone pole is, so we'll just say X. But we do know that a shadow is 144. So what we're going to do is just set up a table. And so we'll go with, we're comparing height to shadow. And we're doing height of both and shadow of both. So it's for the building, the height is 24. And then the shadow is 96. And then now we're talking the telephone pole. We don't know how tall it is, so we'll put X, but we do know its shadow is 144. All right, so what I'm going to do is sort of do like a ratio table. I always tell my students, simplify when possible. Well, half of 24 would be 12. Half of 96 is 48. Now we could do this again. Half of 12 is 6, and then half of 48 would be 24, and then we'll do it again. Sorry about the mess. All right, half of 6 is 3, and then half of 24 is 12. You don't have to do this. You can literally go from 96 to 144, but I thought it was easier to go this route, so whatever works for you. Now, I'm going to go from 12 to 144, and we know that if we scale 12 by 12, we get 144. That means we have to scale the 3 by 12, and we end up with 36. So this is 36 feet is how tall that telephone pole is. All right, let's do another problem. So in this one, it really is similar triangles. You solve them the exact same way. I personally don't like to leave the triangle like this. I always recommend students to just separate them. So we'll do a large triangle and then a small triangle. So the bottom of the large triangle is 18, and the bottom of the small triangle is 6. Now we need a third number, which is given to us in the word problem, and it's 30 inches. So AC, which is the larger triangle, that means the left side would be 30. So now we'll set it up. So I say the large to small. So in other words, on the left side, the only thing I can put are values that go with the large, which would be 30 and 18. And then 18 corresponds to 6. So now we're trying to figure out when 18 is 6, what is 30? Okay, so you can easily, some of you may already see a relationship, but I always suggest simplify if you can. These are both even, so this can become 9 and 3, and then I can simplify it again and divide both of them by 3 or scale down by 3. And then this becomes 3. 9 divided by 3 is 3. Now it's easy to see. I'm going to scale back up from 3 to 30, which is times 10. And then I'll scale 1 by 10, and that gives me 10. That's not the only way to solve it. You could have easily just went 8. If you see the relationship, 18 becomes 6 by dividing by 3. Divide 30 by 3, and you still end up with 10. So either way works. It's just whatever your preference is. All right, well, thanks for watching. I hope this helped.